Hello, my name is Ardi and we are going to solve practice exercise 3.2 from Morris Mano book. So the question is simplify the Boolean function fxyz is equal to sigma 0, 1 to 5. Okay, now we have 0, 1 to 5 because we have three variables here. Maybe let's convert this 0, 1, 2, and 5 into 3-bit binary. So let's take a note here that 0 in base 10 is equal to 0, 0, 0 in base 2, but in 3 bits. And then for 1 in base 10, we will have 0, 0, 1 in base 2. Okay, and then 2 on base 10, we will have as 0, 1, 0 in base 2, 3 bits. And for 5, we will have 4 plus 1, right? Because that is 4 plus 1, we will have 1, 0, 1 here. And this will be base 2, right? Okay, let me know if I made any mistakes here. But now we will draw the Karnaugh map. So first we draw xy here and we draw z here, and let's prepare the line for the table. Okay, now we will have the xy here start from 0, 0 and then 0, 1, and be careful here, this is not 1, 0, but this is 1, 1. And lastly, we will have 1, 0. And for z, because this is only one variable, we only have 0 and 1. Okay. Now we have the sigma is in 0, 1, 2, and 5. We need to put 1 in this position. Okay. How to do that? Let's see here. We will have 0 here. So 0 in 3-bit binary is 0, 0, 0. So we read it like this, 0, 0, 0. So the x is 0, the y is 0, and the z is 0. So the value of this part here is 1 because 0 is one of this. Okay. The same can be said for 1 here. The binary for 1 is 0, 0, 1. So we read it from the left to the top. So we'll have 0, 0, and 1. So 1 is here. So we put it here for this one here. Okay. Okay, next we need to plug in the 2. Okay, 2 is 0, 1, 0 in binary. So we will need to read it from the left and then to the top. So we'll have 0, 1, 0. So the intersection is in this one. So for the 2, we plug in the 1 here. Okay. And then lastly, we need to do 5. Remember that 5 is 1, 0, 1. Okay. So now let's find out 1 and 0 here. 1, 0. And then 1 is here. So we will have the 1 is here. And for the remaining, we just enter 0. Okay, now what can we do from here? Okay, we can circle the adjacent one here. I think this one and one here is adjacent. So we can circle this one here. And this one and this one is also adjacent because you actually can rotate, you can flip that one, so we can circle this one that is goes through this one here. Okay, and I think we have covered all the one here, and now let's take a look at this first one here, the yellow part here. Okay, for the yellow part here, look what's different. the x is the same, 0, 0, so it is the same. The y is different. We will have 0 and we will have 1 here. So that means that this does not depend on y. Okay, so we can eliminate the y from this part here. And for z, it is 0. We don't see any difference here. So we will have the first part from the yellow one. That will be the x here, but the x is 0. So we need to put out prime. And here we also have that z. So we'll have z here. But z is 0, so we need to put out our prime. Okay, that is for the yellow part. So this is from the yellow part. Okay, now let's move on to the other part. Maybe I just color that pink. This one here. And this one here. Now let's look at what's difference between the pink one. The x is different because the one says 0 and the one says 1. Okay, the y is the same because that is 0 and 0. The z, it's obviously not a difference because z is only one variable here. Okay, so that means that the pink one does not depend on x. We only care about y and z. So let's put that out, y and z. The y here, that is 0 and 0. So we need to put the prime here. And the z is 1, so we don't need to put the prime here. So that is from the pink part here. And I think we got our final answer, which is in this box here. Okay, and I think that's all for this problem. Let me know if you have any confusions or questions in the comments, and see you in the next video. Bye bye.